All right, so this is day 2 of normal distribution notes. The beginning is a warm-up. I would pause the video, try this yourself, see how you do. It's on the empirical rule or the 68, 95, 99.7 rule. Okay, so to check your answers here, suppose during a certain year, ACT scores were normally distributed with a mean of 23 and a standard deviation of 3. What's the probability of having each of these scores? So first off, we want to, and I'm going to end up copying and paste this, we want to put our mean right in the middle, which was 23. And then there's 3 standard deviations to the right. So 1, 2, and then this one's all the way over here, 3, which you could hardly see, but realize there is one, and there is space over here, FYI. It's just that it looks like it's touching the line when I usually show that it isn't touching the line there because it never touches the line. So I'm going to add 3, that's 26, add 3, that's 29, add 3, that's 32, and then I'm also going to do 3 standard deviations to the left, 1, 2, 3, subtract 3, that's 20, subtract 3, that's 17, subtract 3, and that's 14. I'm also going to take the opportunity right now to copy this and then paste it on my other 3 warm-ups. So that I don't have to do it again because it's done the same way each and every single time. Okay, so now it says what's the probability of having a score above 20? So I'm going to use the highlighter to do above 20, which is all of these values right here. So now I need to know each of those percentages. So to remind myself, once again, I will copy and paste this also into each of our warm-ups here. This is 34% and 34%. Right? This is 13.5%. This is 13.5%. This is 2.35% and 2.35%. And this is 0.15% and 0.15%. So I really should have copy and pasted all of this. I'll just use that as a reference to answer each one of these. Okay. All right. So I want above 20. So that's all of this, right? All of that there. So what I like to look at it is this is 50%, then plus that 34, or you can add all of those individually. I'm going to do it the fast way and say 50% plus 34, which is 84%. Right? Do it the smarter way. Work smarter, not harder. Okay, below 17%, that's this and this. So that's 2.35 and 0.15. That's these two right here. So that is 2.5%. Between 14 and 32. Ooh, that's a little off there. Ew, I don't like it. So let's just move it up a little bit. Okay, sorry. All right, so 14 and 32. 14 is here, and then 32 is here. So I would look at it as that is within 3 standard deviations, which remember this is the 68, 95, 99.7 rule. So it's everything but the outsides, or you can add everything in there, right? Or you can do 100 minus this, however you want to think about it. I think of it as 3 standard deviations. That's 99.7%. And then last but not least, 21 and 25. So 21, let me get my red pen, is right here. And 25 is right here. So notice that this is not the empirical rule. So we can't use the 68, 95, 99.7 rule. It's less than 68%, even though this line's crooked, but you know. So what are we supposed to do? We can't use the empirical rule. So that's what our lesson is on today. What if we can't use the empirical rule? So if we can't use the empirical rule, we can use technology to get the answer. So it says we can answer this question about proportions above. It doesn't say that, but we can answer D by using technology. Okay, so we can do the empirical questions too, but why not just use the rule instead of a calculator when we can? Okay, so when we can't, here are examples of when we can't. So it says the level of cholesterol in the blood is important because high cholesterol levels may increase the risk of heart disease. The distribution of blood cholesterol for 14-year-old boys is approximately normal, with the mean being 170 milligrams of cholesterol per deciliter of blood. And the standard deviation is 30 milligrams per deciliter of blood. So levels above 240 may require medical attention. Okay, so what we're going to end up using on our calculator is the VARS button. So there's a VARS button on your calculator. I'll show you where it is when we get to it. You're going to hit second and then VARS, because right above that it says distribution, and that's what we're using. We're using distribution. Then our calculators might look different. So if you have an older calculator, not older, but like a TI-83, it might be brand new to you, right? Then our second option is normal CDF. Let me click here. Our second option is normal CDF. And you would choose that for normal distribution. And then you're going to list these 4 things, right? So you're going to do the lower bound, which sometimes I abbreviate LB, right? The upper bound, and I'll explain what each one of these are, UB. The mean and standard deviation. So remember, mean is mu, standard deviation is sigma. So if you have a TI-83, what you're going to do is you're going to write down what the lower bound is, then you're going to put a comma, the upper bound, comma, the mean, comma, standard deviation, comma. I'll show you where the comma button is in case you have a calculator like that. I have a TI-84 on mine, on my iPad, so mine looks a little bit different. I'll show you that also. Okay, so let's go ahead and get started on this problem right here. What percent of 14-year-old boys have more than 240 milligrams of cholesterol? So first off, we can't use the empirical rule on this. I didn't explain why on that. Is because for this first question here is that if you think about, let's go ahead and draw what this looks like. So I'm going to draw my bell-shaped curve here. I like to leave space so that it doesn't hit there. So if I put the mean right there, which was 170. So let me write this down so I can see it here. The mean was 170 and the standard deviation is 30. Okay, so this is 170. And then I'm going to do 3 standard deviations to the right. 1, 2, 3. So add 30, 200, 230, 260. And then subtract 30, 3 standard deviations to the left. 140, 110, and 80. And then I'll just copy and paste this and use this for all of my questions here. Okay, so the reason we can't use the empirical rule, you can see here, is 240 is not within 1, 2, or 3 standard deviations of the mean. So let's see where 240 falls. Okay, 240 would be like right here-ish, let's say. All right, that's 240. Okay. And it says what percent of 14-year-old boys have more than 240, right? So I'll highlight where that is. My pen went out, sorry. Right here, I want this, okay? So what we're going to do is we're going to use our calculator. We're going to use normal CDF. Now, we're going to use normal CDF. Let me write it down first. We're going to use normal CDF when we are trying to find a shaded area. So use this when trying to find shaded area. Shaded area. So you're going to be trying to find the shaded area. And like a lot of times the questions are posed as what's the percentage or what's the probability, or what proportion of students, people, whatever is talking about. So when you see those words, we're going to use normal CDF, okay? All right, so we want our lower bound first. This is our lower bound, which is 240. Our upper bound goes forever. So forever is infinity, right? That's forever, okay? But we don't have an infinity button on our calculator, so when you're doing infinity, what we're going to do is we're going to do 1E99. So what that tells our calculator to do is take the number 1.0, and move the decimal 99 places to the right. So it's making this huge number. And then when we want negative infinity, we're going to do negative 1E99. Okay, and once again, that's 1.0, and it's moving the decimal 99 places to the left. Okay, it's just making it a very small number. So our upper bound is infinity, so we're going to use 1E99, comma, our mean, which is 170, and our standard deviation, which is 30. All right, so now we need to put that in our calculator. So I'm going to pull out my calculator, put it over here to the right. Move it over a little bit so it's not taking up too much of my screen here. Okay, so it tells us what to do right here. We're going into the VARs. We're hitting the VARs button, okay? We hit second VARs because we want distribution. So if you see the VARs button, it's immediately to the left of the clear button. So the clear is on the right-hand side of your screen. And then VARs is directly next to that. Right above it, it says DISTR. That's distributions, which is what we're doing. So we're going to hit second, which is the blue button on my upper left-hand corner here. And then I'm going to hit VARs, which is distribution. Option number 2 is normal CDF. Now, if you have an 84, you're going to type 240. And then you're going to hit the comma button. The comma is right above the number 7. Now, on my calculator, it just asks you for each one, so I just have to fill in each one. So the upper bound is infinity, so I'm going to hit the 1. Then I need E. E is at the comma button also. It says EE, right? You see above the comma button, it says EE, so we're going to hit second comma. That'll give us the E, and then 99. That's infinity. Well, it's not infinity, but it's as close as infinity we're going to get. Our standard deviation is 170. And then our standard deviation is 30. Then we're going to go down to paste. What's going to do, it's going to paste it into our calculator. We're going to hit enter. And then it tells us our percentage. Or sorry, it says what percent. So it's going to tell us it as a decimal. So the decimal we get is 0.0098. So I'm going to say 0.10. Now that is written as a... it's not written as a percentage, I should say. So now let's write it as a percentage. So I'm going to say approximately, and then I'll move the decimal over 2 places to the right, and I get approximately 1.0%. Okay. All right, next it says, what percentage of 14-year-old boys has less than 120 micrograms? What was it? Milligrams per deciliter? Yeah. And then what I'm going to do is I'm going to copy and paste this, which what I should have done. Copy, paste. All right, what we're looking for now, I'm going to get rid of what I highlighted already. All right, so what we're looking for now is we're looking for 120, have less than 120. So 120 falls right here, and we want less, so that's all this right here. So we're looking for a shaded region once again, so we're going to use normal CDF. Our lower bound, that's this way over here, right? That's negative infinity, so we're going to use negative 1E99. Comma, our upper bound, which is right here, that's our 120. Our standard deviation is 170, our mean is 170, our standard deviation is 30. So now we're going to put this in our calculator. So once again, we're going to hit second, VARs. Option number 2 is normal CDF. Our lower bound is negative 1. Second comma, which gives us this E99. Our upper bound is 120. And then our standard deviation and mean are still in there. Hit paste, hit enter. And once again, this tells us what percentage. So I'm going to write 0.048. Move the decimal over 2 places to the right. So approximately 4.8%. And you can write about 4.8%. You just write 4.8%, and I'm fine with that. All right, lastly, what percentage of 14-year-old boys has between 105 and 175? So once again, I'm going to paste this here. Sorry if you hear my dog. Okay, so that's in between 105 and 175. So 105 is right here. 175 is right here. So the reason I'm showing a picture of this to show is that you can't use the empirical rule. So we want this right here. This is 105. This is 175. Can't use the empirical rule, so I can use technology. I'm going to write down normal CDF. You want to show what you're typing in your calculator. You can't just type it and put an answer, right? Lower bound is 105. Upper bound is 175. Mean is still 170. Standard deviation is still 30. So this is just showing you, if you had to do negative infinity to a number to positive infinity, or in between 2 numbers, how to do each one. All right, so normal CDF, option number 2, I'm going to change my lower bound to 105, my upper bound to 175. Mean and standard deviation are already correct. I'm going to go down to paste, enter, enter. 0.551, and then it says what percentage, so move the decimal over 2 places, 55.1%. Okay? All right, so next we have working backwards, okay? So working backwards is going to give you a shaded area, and you have to find the values, okay? So you're going to do this when you're looking for a value, okay? We're working backwards. We're still going to do second vars to get here, and then we're going to choose inverse norm, okay? So for inverse norm, you're going to need 3 numbers. The first number is the area to the left in decimal form. So you don't want to, if it's 80%, you want to put 0.8. Comma, mu, comma, standard deviation. Okay? So it's important that we're doing area to the left. It's because if you have a TI 83, that's the only number that'll accept. If you have a TI 84, color plus whatever, you could actually choose whatever one you want and then choose the area. We're just going to keep it standard area to the left so we can all be doing the same thing. Okay. All right, so let's see what these types of problems look like. It says, the scores for the entrance exam for a college mathematics department is normally distributed with a mean of 65 and a standard deviation of 8. So normally distributive, mean of 65, standard deviation of 8. If Ramona wants to score in the 80th percentile, so they gave us a shaded area. What score must she earn? We want to find X, right? We want to find that value. So that's why we're going to use inverse norm, right? All right, so I know I'm using inverse norm, and I'm using technology here. Inverse norm. And then my first number is the area to the left. So if she wants to score in the 80th percentile, okay, that looks like this picture shown here, okay? But we want the area to the left of that value. So this value, it's this value right here, we're going to put in the area to the left, which is 0.8. So we're going to do 0.8, comma, mean, which is 65, standard deviation, which is 8. And we're going to put that in our calculator. So we're going to hit second vars, which is distribution. Option number 3, so I'm going to write that down right there. Option number 3 is inverse norm. So once again, if you have a TI 83, you're going to put 0.8. Okay, 0.8. Comma, your mean, which is 65, and then your standard deviation is 8. Now, some calculators, like if you have a color calculator, it now also underneath that, it says, let me look at my calculator that I have in front of me because it says something else underneath that. Oh, it says tail, left, center, or right. Just keep it on left. And so like technically you could have done right and 0.2 and it'll give you the right answer, but let's just all keep it left and always do the area to the left. Hit paste, hit enter, and it's going to tell you what that value is. So that value is 71.733. And that's a score, so I don't have to put minutes or people or whatever we're talking about, but they would need to earn a score of 71.733 to score in the top 80 percentile. Yeah? Okay. Next, it says most students earn between the middle 90% of the distribution. What range of values does this fall? So we want this and this. We want 2x values. So I have to find this value, and then I'm going to find this value, and then I'll say it's in between those two. Since we want values and not areas, we're using inverse norm. So I'm going to do inverse norm. And I will start with this value right here. So I need the area to the left. So I need this area first. So I already know this is 90. That means this and this make 10% together. And 10% divided by 2 is each one of those is 5%. So once again, to get that, I did 100 minus 90, which is 10, and then I divided that by 2. So I know this is 5%, so I'm going to put 0.05 and 5%, 0.05, right? So this one's going to be 0.05 for the area to the left, and then the mean still 65, standard deviation 8. That'll give me that value. Now I also want to find this value right here. Let me change colors so you can see what I'm talking about. I want to find this value right here. So I'm also going to use inverse norm for that. I need the area to the left. So I need this area. That's 90 plus 5%. It's not 90 plus 0.05. This is just written. So like if I write it like that. So 0.9 plus 0.05, which this whole part is 0.95, right? So 0.95, because that's 95%, comma 65, comma 8. Okay? All right, so now I'm going to put both of those in my calculator, and then I'll have the two values it's in between. All right, so second variable, second bars, option number 3, I'm going to do 0.05, standard deviation 65, or sorry, mean 65, standard deviation 8. And my first value is 51.841. And then I'm going to go ahead and do this again. Second vars, option number 3, I'm going to change this area to 0.95. And then those are both still correct. Hit paste, hit enter, and I get 78.159. 78.159. So the scores have to be in between those two, and it's the x value has to be in between those two. So how we can write our answer is x has to be in between 51.841 and 78.159. You could also write it as a sentence. You can write in between 51.841 and 78.159. All right, so I have two problems here that have parts A and B for you to try. If you want to pause the video and try them yourself, it's a mixture of using both of those functions in your calculator. If not, I'll show you how to do them right now. So it says the temperature for 1 month for our city in California are normally distributed. So normally distributed with a mean of 81 and a standard deviation of 6. Find the percentage of temperatures that were between 70 and 90. So first off, I want to see if I don't have to use technology. So I'm going to draw my bell-shaped curve here. My mean is 81. And then standard deviation, 3 to the right, 1, 2, 3, plus 6 is 87, plus 6 is 93, and then 99. 3 to the left, 1, 2, 3, subtract 6, 75, 69, subtract 6, 63. Okay, so I want between 70 and 90. So 70 is here, 90 is here. Definitely can't use the empirical rule, but I want this shaded region right here. So since I'm using a shaded region, what percentage? I'm using normal CDF. So I'm going to do normal CDF. And then once again, remember those values are the the lower bound, the upper bound, mu comma theta. So the lower bound was 70. The upper bound was 90. The mean was 81. The standard deviation was 6. So I'm going to put that in my calculator. Second vars, option number 2, normal CDF. Lower bound is 70. Upper bound is 90. Standard deviation is 81 and 6. Or sorry, mean is 81, standard deviation is 6. All right, and I'm going to write it as a decimal first. 3 decimal places is 0.900. So I'm going to say approximately 90.0%. That's my answer. Or you can write about 90%. That's also fine. All right, next question. Find the interval that contains the middle 50% of temperature. So I'm not looking for a percentage. I'm looking for two x values. I'm looking for this x value and this x value. So I'll start with the one on the left here. And I'm using inverse norm if I'm looking for x value. So I'm going to do inverse norm. All right, so I need the shaded area to the left, which is already labeled for me, which is great, which is 0.25, comma, mean is 81, standard deviation is 6. And then I need my other x value, so I'm going to do inverse norm. The area to the left, so this area this way, is 50 plus 75, so that's 0.75. 81, comma 6. All right, so I'm going to put both of those in my calculator. So second vars, option number 3, inverse norm, 0.25, 81, 6, paste, enter, and I got this is 76.953. The next one, second bars, option number 3, inverse norm. Change that to a 0.75. Paste again, hit enter, and I get 85.047. So once again, this is temperatures. So in between these two temperatures, right, I'm going to put degrees on them. 76.953 degrees, and 85.047 degrees. And once again, you can write it in words. You can say in between these 2 degrees. All right, next problem, the last problem for you to try. The distribution of heights of an adult American men is approximately normal. So we have normal distribution with a mean of 69 and a standard deviation of 2.5 inches. Between what heights do the middle 95% of men fall? Okay, so I want to know 2x value, so I'm going to use the inverse norm twice again here. But just so I can have, just so I can have an idea of, not an idea, but I need to know that lower bound, that area to the left. I'm going to draw a picture for this. I'm having a hard time making my, there we go, curve. There we go. Okay, so the middle 95, so let's just say that's from here to here. This is 0.95, okay? So if I do 100 minus 95, that's 5, divided by 2, that's 2.5. So this is 2.5% and this is 2.5%. But I'm going to write it as a decimal, 0.025, 0.025. Okay? All right, so I need to find each of those x values, each of those little lines right there. So I'm using inverse norm. Inverse norm. Area to the left of this value, which is 0.025. Standard deviation, mean standard deviation. I keep saying standard deviation first. And then for the second one, this one right here, inverse norm. Area to the left, which is 0.95 plus 0.025, which is 0.975 or 97.5%. 97.5%. Oops, I put too many decimals in there. Here. There we go. 69,2.5. All right, put both of those in my calculator. Second, VARS. Option number 3, inverse norm. 0.025. 69, 2.5. All right, type that right, hit enter, enter, enter. All right, so I get my first value, 3 decimal places, is 64.100, and then do it again. Option number 3, 0.975. Everything else is the same, which is nice when you're doing these. It's like if you have this type of calculator, if not, you have to type it twice. 73.900 because it's 8,999. All right, so now I'm going to write it as an in-between statement. You can write it in words also, but make sure you put the label of inches on it. So I'm going to say 64.100 inches and 73.900 inches. So there's my... I bought this new pen and I'm not in love with it. Let's just say that. All right, there you go. Okay. Last question, part B. What percent of men are taller than 6 feet 4 inches? So first off, I need to make that all inches, right? So 6 times 12 is 72 plus 4 is 76 inches. So this is 76 inches, all right? Okay, so I could draw this. I'm going to, just so you can see that you can't use the empirical rule. So our mean was 69. Our standard deviation is 2.5. So 3 standard deviations to the right. 69 plus 2.5 is 71.5. Plus 2.5 is 74. Plus 2.5 is 76.5. Okay, so we want more than 76 inches. 76 inches is right here, and we want this. That's not using, I can't use the empirical rule, right? So I am looking for a percentage. I'm using normal CDF. So normal CDF Lower bound, so this value right here, which was the 76. Upper bound is forever, so I'm going to use 1, E99. Comma, mu, which is 69, standard deviation, which is 2.5. And I'm going to put that in my calculator. Second, VARS, option number 2, normal CDF. Lower bound, 76. Upper bound, 1, E99. Mu, 69. Sigma, 2.5. Paste, enter, 0.003. Move the decimal over 2 places to the right. So about 0.3%, which makes sense. There's not a lot of people taller than 6'4", right? All right, that's it for today. So once again, if you can't use the empirical rule, you can use your calculator for to use technology to get your answers. If you're looking for a percentage or a proportion, you use normal CDF. If you're looking for values, you use inverse norm.